Hi, this is a recorded lecture for the IB/DP Design Technology Topic 4.5 Production Systems. This is from the IB. You're expected to have a deep enough understanding of production systems to be able to make sound decisions when determining which production system is appropriate for a specific job. This includes being able to explain advantages and disadvantages of different production systems and the impact that they have on the workforce, environment, and selection criteria. This is important for criterion F of your IA, and so it's something that you need to pay attention to. We're going to talk about advantages and disadvantages of production systems in the following areas. That's economies of scale, value of the product, labor, market forces, and the flexibility of manufacturing. And the first production system we're going to talk about is craft production. So this is small scale production that's centered on manual skills. This connects to one-off production and possibly batch production, but this is bespoke, custom, and individualized production. And you can think of things like jewelry making. For instance, here, if you go to a jeweler and have a custom ring made, this would be craft production. You're having a one-of-a-kind, bespoke, custom, individualized ring made for your finger or for somebody's finger. And so it's craft production. Now, the advantages and disadvantages of craft production are this. They really don't have much of an economy of scale, so that's not going to be an advantage at all. Disadvantages are they're small scale, it's more expensive, the prices are higher, and labor costs are high. For the value of production, it may or may not require machines, and there's a high quality usually. However, a disadvantage is that it's more time and effort and more expensive for the buyer, and there's problems with defects. If you have a problem with a product that you've produced, you could be out a lot of money. For labor, you need highly skilled craftsmen, and the labor costs are high because training takes a long time, so that's a disadvantage. And it can be quite slow. For the market forces, care is put into making the product. Typically, craftspeople are super proud and careful with their products that they're making. They tend to be higher quality than something that is mass produced. For flexibility, you can customize and fit to personal needs. So for instance, going back to the jewelry example, you can customize it to fit your finger. And it's flexible for the designer, customer, and the craftsman. However, a disadvantage is the product may not be designed for disassembly, and there's probably no interchangeable parts because it's made for somebody. It's bespoke, it's individualized. So it's not like you're going to be able to swap out a part. You'll have to remake that part, and again, that's going to have a lot of costs. So it can be quite expensive for the buyer. With mechanized production, this is a volume production process involving machines controlled by people. Please watch this video. It shows the machining process. So these are machines controlled by people, and the advantages and disadvantages of mechanized production are, again, economies of scale are low because you're making things on small scale. It's expensive, and milled products are, of course, going to be higher prices on those. Another advantage, though, is for the value of the product. It's going to require machines, and so it's also going to be quite high quality usually. It requires machines. That is a disadvantage. It can be slow, it's expensive for the buyer, and again, defects are expensive. An advantage for labor is that the labor costs are higher. So laborers get paid more, but this is also a disadvantage if you're a company. You need a lot of skill. Highly skilled means highly paid. This also is a disadvantage because training takes a long time, and there's more likelihood of human error whenever humans are involved in some sort of production process. More care is taken for making the product, and you generally get higher quality products than, say, mass produced. Another advantage is in the flexibility of manufacturing. You can customize to fit specific situations, and there's a good deal of flexibility for the designer, customer, and machinist. A disadvantage might be that products may not be designed for disassembly. You may not have interchangeable parts, and so this can also mean that things are more expensive for the buyer. Automated production is a bit like mechanized production, except instead of people controlling machines, we're using computers. So this is a production process involving machines controlled by computers. You do get better economies of scale because you're producing at a larger scale usually. That means that the raw materials and components are less expensive, which can mean higher profit. But the machine costs are very high to set this up. It's less expensive for the buyer, so that's the value of the product, than compared to mechanized or craft production. Errors cost less due to higher volume. So if you have a problem with one piece, increase. It's not going to break the bank like it would with craft or mechanized production. You get better precision because you've taken the human out of this, so things are exactly the way they should be because the machines are producing them. But it does require machines, and that's a disadvantage, and the designs take more time and effort because you need to get them right, because computers will follow the directions you give them, and if you give them poor directions, they will make a poor quality product. You need highly skilled people for the designing and computer engineering aspect of this production system, but at that point you can use low skilled labor because the machines are actually running. So essentially the low skilled labor are people who are making sure the machines are doing what they should be doing. But you can have increased competitiveness because your labor costs are lower. It's slower than mass production and there's less skilled labor, and that means that the labor can be quite dissatisfied with their jobs because they tend to be quite boring jobs and not very interesting. You do get higher consistency than compared to mechanized production, and that means you have greater quality control and quality assurance, but there's less care put into the product by the low skilled labor force. You got a little bit less flexibility, so you'll see it's less customizable over here and less flexible for the designer and the customer, but some advantages are that you can design things for disassembly, you can have interchangeable parts, and it can be less expensive for the buyer. Assembly line production is a volume production process where products and components are moved continuously along a conveyor. As the product goes from one workstation to another, components are added until the final product is assembled. Generally, assembly line production is for large products that have a lot of different components. So you can think of a car or a dishwasher or a refrigerator or a clothes washing machine. These are the kinds of things that would be on an assembly line. You should also watch these videos. So this is an assembly line in the past. I think it's 1950s, 1960s. It's a Volkswagen assembly line, and this is a current Volkswagen assembly line. So you can kind of compare the difference to the two. With assembly line production, you have advantages and disadvantages, just like the other types of production. So you do get economies of scale, it's less expensive, so higher profit, and the assembled products have lower prices, but the machine costs are very high. Just like with automated production, it's going to be less expensive for the buyer. You're going to have fewer errors and you're going to have better precision. But it's going to require machines, and the design takes a lot more time and effort. So you are going to need very skilled designers and computer engineers. But generally, you have low skilled labor once you've got the thing rolling along. It increases competitiveness because of the low cost. It's slower than mass production. It has less skilled labor than craft or mechanized, and therefore you can have some labor dissatisfaction. You're going to have higher consistency, just like with automated, and greater quality control and quality assurance. But of course, the individual workers probably care less about the products that they make. It's not very flexible, so less customizable and less flexible, but you can design for disassembly, have interchangeable parts, and it's less expensive for the buyers. Mass production is the production of large amounts of standardized products on production lines, permitting very high rates of production per worker. And this is an example of mass production, how Lego bricks are made, and you should have a watch of that. Now, the big difference between, I would say, mass production and assembly line production is generally with mass production, you are producing parts and components that are not as complex as, say, an assembly line. It's going to have fewer parts, and generally it's going to have sort of like one step for the part rather than many steps. All right, so let's look at the advantages and disadvantages of mass production. Just like with assembly line production and automated production, you're going to benefit from that large scale production. So the economies of scale, so you're going to have higher profits because it's less expensive for the raw materials, and the assembled products are going to be lower prices. But of course, the machines are quite expensive. We're going to have less expense for the buyer, less errors, and better precision, but it requires machines, and the design takes more time and effort. You're going to need highly skilled designers and computer engineers, but then you have low skilled laborers, which makes labor costs low. That less skilled labor force is also sometimes more dissatisfied. You're going to have higher consistency, but it's going to have less care because the laborers don't necessarily care as much about any individual product. You can design for disassembly and interchangeable parts, and it's less expensive for the buyer, but just like the other ones that we just talked about, it's less customizable and less flexible for the designer and customer. This brings us to computer numeric control, or CNC. This refers to computer control of machines for the purpose of manufacturing complex parts in metal and other materials. Machines are controlled by a program commonly called a G-code. Each code is assigned to a particular operation or process, and the codes control an X, Y, and Z movement, and then the feed speed of the machine. And you can see here that we have two types of subtractive manufacturing and one type of additive manufacturing. So 3D printing is additive manufacturing. And when you put the G code in the machine, it essentially tells the print head what are the X, Y, Z movements that it needs to make and at what rate should it feed the filament into the print head. And that's what the G code is. For a laser cutter and a CNC router, it's the same idea. It's basically telling the laser or the router where it should be in space, so it's XYZ movements, and how fast it should be moving in subtracting that material. Mass customization. This is a sophisticated computer integrated manufacturing system that manufactures products to individual customer orders. The benefits of economy of scale are gained, and this is whether you're making something like a single item or thousands. And please watch this video. It's really interesting and shows you mass customization. When we're talking about design for manufacture, we need to consider four aspects. We need to consider design for materials, design for process, design for assembly, and design for disassembly. So design for materials is designing in relation to the materials during processing. So what materials are best suited for the function and easy to manufacture. And we use things like these material selection charts in order to help us choose which are the best materials for a particular manufacturing technique. You should be using these in Criterion A as part of your research and in Criterion C as part of a justification for materials that you're choosing in your IA. Design for process involves designing to enable the product to be manufactured using a specific manufacturing process. For example, injection molding. So this is an injection molder right here. You add plastic into the hopper, it's heated, it's pressed into a die or a mold, and it is then extracted from that die and mold after it's cooled. Now, it's important when you're designing that you design in a very specific way, because you have to think of things like the release of the product from the molds. And so that's part of this design for process. You can't just injection mold everything. There are products that would not be able to be injection molded because it needs to be able to come out of the actual mold that it's injected into. Designing for assembly takes into account the assembly at various levels. For example, component to component, component to sub-assemblies, and sub-assemblies to the complete product. And it's also taking into account, can we make things have fewer parts or components? So for instance, if you look at the progression from A through D on this part, you can see that there are a reduction of the number of components as you go from A to D. Design for disassembly involves designing a product so that when it becomes obsolete, it can be easily and economically taken apart and components reused or repaired, and the materials repurposed or recycled. This is just an example of Fairphone, and we'll talk about them in just a second. But Fairphone creates cell phones that can be taken apart and repaired or parts replaced to upgrade them so that it can last longer. But you can also think of this with fastenings. So when we talked about joining together materials and we talked about temporary versus permanent connections and joining techniques, in topic 4.4, you can think of this also like it's easier to take out a screw than it is to take out a rivet. So if you're designing for disassembly, you're going to be thinking about that sort of thing. Can I use screws in this particular product rather than rivets because they can be disassembled much easier? This is an example of Fairphone. You can click on their website and have a good look through there. But their business model is to try to make phones that are long lasting and that can be repaired and upgraded so that you don't have to throw away the whole phone. This is OpenDesk. This is a mass customization type product, and they make furniture that you can make bespoke. It's mass customization, so it's that idea that we just talked about in productions. And then this is craft production. So for instance, Etsy, where you can buy yourself, oh, I'm going to buy a customized piece of pottery. That's something that you could buy on Etsy, and that would be craft production. One last production system that we want to quickly just talk about. This goes with user-centered design and UX design, which is user experience design. And these are paper-based rapid prototyping or wireframes. They're often the first step in a rapid prototyping process. Paper prototyping is widely used in UCD for designing and testing interfaces. All right, thank you for watching.